Units for rate and rate constant. In the previous video, we looked at this example here, but when we found K and we found the rate, okay, but we didn't include the units over here in order to get our seconds. Obviously, we knew the ending was going to be seconds because our rate here is in time seconds anyway, okay, but in this video, we're going to look at how our units cancel out here. And for K, we didn't put the units, okay, but we're going to be putting it now, okay. In the last previous videos, rate law and rate law practice questions, see the link in the description for those, okay. We, out of complexity, okay, and for the sake of time, we excluded them, but we're going to be showing you how you do it in this video. So how do we find units for this K, this 0.1248? Well, we're just going to use our rate law that we found up here. So this 0.01 to the power of -1 gives you here 100. This 0.08 to the power of -1 gives you 12.5. You multiply them, you get 1,250. You just bring this and this, you just bring it back down here. And then obviously we have to isolate for K, so we have to divide this by 1,250 moles squared over liter squared. If I do it on the right side so that they can cancel out, I have to do it on the left side. So this is also divided by 1,250 moles squared over liter squared. Okay, so let's solely solve for the units out of simplicity. So we'll leave the numerical values out of it. We know that we're going to be ending up getting 0.1248 anyway. Okay, but we're just going to solely look at the units. Okay, so this S divided by mole squared over liter squared, as is shown here. Okay, S over nothing is technically over 1. Now I'm just going to simplify my S over 1 into 1 over S by changing this divided symbol into multiplication like here. Okay, so technically this becomes 1 over S. 1 over S is the same as S to the power of -1 because 1 is in the numerator. Mole squared over liter squared goes down and nothing changes, so our final answer is S to the -1 moles squared over liter squared. How do we find the units for the rate? Okay, so for the rate, I'm just going to use that K that we found. It's universal for all these trials, so I'll just add it over here, multiplied by our rate law. Okay, so our rate law over here was for trial number 4, so I'll just write this here. It was for trial number 4 because we're trying to look for the rate for that one. Our concentration was 0.02. I've added it here. It's to the exponent of -1 like we found in the previous video. Same thing here, -1. Okay, you multiply them, you obviously get 0.02 to the -1, 0.02 to the -1, you get 50, and you get 50. You multiply them, you get 2,500. Okay, our moles here, add the exponents, mole squared, same thing for the liter squared. Now this 1248, okay, 0.1248, it's in seconds. Okay, I obviously want to keep the seconds, so that's why I don't want to make it S to the -1 like we did here. I'm going to restart, I'm going to back up, and I'm going to leave my seconds the way it is, but instead I'm going to change the divided to the multiplication so that the moles squared and liter squared flips. Okay, so that's why we've done it this way. Why? Because then the liters and liters can cancel out. These moles squared, these moles squared can cancel out. So I'm just left with my 312 with these numerical values multiplying as a product, and our seconds is over there. This is the answer.